By now, you know tokenization breaks text into pieces. But how? What's the algorithm? In this video, we'll dive deep into it. BPE or Byte-Pair Encoding is a Subword tokenization algorithm which works in iterations. In each iteration, it finds the most common pair of consecutive tokens and merges them into a single new token. Let me give you an example. Imagine you start with individual characters of hello. It becomes HELLO. Now scan through all your text and count what pair appears most often. Maybe it's L followed by L. That pair appears thousands of times. So you will merge them into a new token LL. Now your text has HELLO. You keep repeating this process thousands of times. Each iteration creates new, more meaningful tokens. Eventually, hello becomes a single token instead of 5 characters. Now we will see why BPE works so well. First, efficiency. BPE discovers the most common patterns and creates tokens for them. But it also balances vocabulary size with token sequence length. This keeps inference fast and cost effective. That's crucial because every token costs money when you are calling an API. Second, vocabulary handling. Unknown words are handled gracefully. Unhappiness becomes unhappiness. Third, multilingual support. Byte level BPE handles any Unicode symbol. English, Japanese, Arabic, emojis, code, it all works. That's why it's so universal. Now, ChatGPT uses byte level BPE optimized through a library called TikToken, what we have discussed already in the last video. GPT-4 uses CL100K base, that is 1 lakh base tokens. GPT-4 uses C200K base, that is 2 lakh tokens. Claude uses a specified Subword tokenization method similar to BPE with around 65,000 token variations. The exact implementation differs slightly from OpenAI's, but the core principle is the same. It's deterministic and learned from data. Once trained, it always produces the same output and it adapts to whatever data you trained it on. Now, let's see the actual BPE code. This is simplified, but it shows the core algorithm. First, see HuggingFace transformers. There are lines to load the tokenizer, you import the auto tokenizer, then call from pre-trained with any model name. Say GPT-2, BART, Llama, Claude, it works for all of them. Then, you tokenize your text. For example, tokenization breaks text into pieces. You call encode and get back token IDs. Look at the output. So there are 7 token IDs. That's BPE working. A 31 character sentence becomes just 7 tokens. That's the compression and it brings the efficiency. And notice you can decode it back. Pass those token IDs to decode and you will get the original text back. Now let's look at TikToken, OpenAI's official tokenizer. This is what powers GPT-4. You import TikToken, then call get encoding with CL100K base. That's GPT-4's encoding. That is 1 lakh base tokens. Then the exact same flow. Encode your text, get token IDs back, decode to verify. So we have used the same sentence. Tokenization breaks text into pieces, but this time we will be getting different token IDs than the HuggingFace ones. Why? Because TikToken was trained on different data with different merging patterns. So, by now you have seen BPE in action. 2 different libraries, but the same core principle, but different outputs. In the next video, we are diving deeper. We are going to explore how these tokens become embeddings. If you find this video helpful, please like, subscribe to my channel and hit the bell icon. And if you have any questions about tokenization or want to see more code examples, drop a comment below. I will see you in the next one. Till then, goodbye and happy learning.